Now, sometimes we the syntax allow to specify the data type, but it's not necessary. Sometimes people omit the data type. Okay. So this would be the name of the attribute, and then after the column is the data type. Sometimes they put the data type first. The general idea is that this is the class name, attributes, and methods. So this is the general idea. There's some variations in the middle. It's not really that strict. Now, what do we mean when we say there are relationships between classes? So let's say we are creating a payroll system. Now we have two classes. I have I'm gonna write the class the employee, and you write the class of manager. Now we have to understand that there are some relationships between these classes. What kind of relationships we can have between the classes in the UML, the class diagram? There is what we call the has-a relationship, and another name is the actual official name is association. Has-a is just how do you describe the relationship? Okay, if you describe two classes, like one of them has the other, or objects, one of them has the other, like a student has an address. Okay, a course has students. A car has a manufacturer. Okay, so when you describe the relationship with has-a, it is a general association. Uses a, so when you describe relationship with the user uses a term, it means it is a dependency. So this is the dependency is the kind of relationship we use when you, so we're gonna see how it is implemented. So has as just one of the attributes. Uses is just an object of the other class is created at some point, but it's not an attribute. It's not a general aspect of the other class. Is made of, there are two types, the aggregation and composition. So when you say, so let's say a car is made of brake system and steering system and blah 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 is made of. Okay, so one set of objects, when they put together, they create another, or the other object is this aggregation of the set of others. Is the inheritance relationship, like the manager and employee. So when you say a manager is an employee, right? So that's inheritance. These are the general relationships. How do they look like on the diagram? So this is the has or the general association. It's just a line between the two classes, and it may have a name. This name should be a verb to describe. Now, the has is the very general verb. Now, if we can describe the relationship with a more specific verb, it would be better. Okay. Now, instead of saying that like a course has students, it's better to say students are enrolled in a course. And it's still under the has-a category. It's still called association, but the name on the diagram would make it easier what you intend from this relationship. Okay, makes it easier to understand what you intend from the relationship. Now, in addition to linking between the two classes and describing the intention of the relationship, you have what we call the multiplicity. So multiplicity just describes how many objects from each side would be participating in this relationship. Okay, so multiplicity would be in the form of minimum to maximum. So when the minimum is 0, it means that the participation is optional. So you can have a student that doesn't have an address. That's what it means. So participation is optional, means we can have one object of the students that is not linked to any of the objects in the address. When the minimum is 1, it means that every object must be participating in the relationship. Okay, so minimum is 1 means every object must participate in the relationship, which means here in this example, every object of address must be associated with one student at least. Okay, When the maximum is 1, it means that it's only one other object. So when it's linked, in that case, when it's linked, when a student is linked to an address, it cannot be more than one address. It must be exactly one. Okay? When the maximum is star, so star means many, any number. So here it means that an address, an object of address could be associated to many number of students. Okay, sometimes they put a particular number. So if you know that it's exactly 5, so maximum is 5, sometimes you put this number, but the star just means multiple. Okay, without specifying a specific number. Now we can also have an arrow that describes the visibility. So who is going to need access to which? Which object needs to access to which object? Now, what does that mean? If you are inside the address here, do you think in any of the functions here, any of the lines in the code, you will need to access the object the student to do any processing on it? It's not likely, right? It makes more sense that inside the code of the students, you may need access to the address object to do some processing in it, at least to return it or to set it. So that means that the student needs access to the object, the address object. So when you get to implement it, so this arrow means that the students see the object of the student can see the objects of the address so that it can have some lines of code that reference it. Okay? And that determines when we get to implement it, when you get to write the code, now you're gonna create a variable inside the student that is of type address, or that would point to the address. If it was the other way around, so if you have the arrow other way around, you will have a variable inside the address that would point to the student object. Okay, so that's what the arrow means. Now, the other type of relationship, now some people think of it as a special type of associations, which is made of, that is actually the aggregation and the composition. When you have one object, so let's say, for example, a course, this is the hall, and students. So student is part of a course, and multiple students would constitute a course. Or course is aggregation of a group of students. Okay, composition is when the parts cannot exist independently. So for example, if you delete a course, the students' objects don't disappear from the system, right? They still would exist in the system for other reasons. But when you have something like house and room, or chair and legs, or car as a whole and wheels, when the car object disappear, there is no point of the wheel objects to remain. Or if the chair object disappear or deleted, there is no point of having the legs object remain. Okay, so that kind of relationship is called the composition. Okay, so there are two types of the is made of relationship. There is the aggregation and the composition. Both of them are described with a diamond that is drawn at the side of the hole, the big part. Okay, if it's solid, then it's composition, and if it's empty, then it's aggregation. Now that, like you see, that's just one symbol. When I give you a diagram that has this symbol, now you have to write your code so that it implements that meaning. Okay, so when there is an object that it gets deleted and you know that it's composition, you have to make sure that all its components are deleted as well. Okay. Now here's an example. When you have, say, a student club, it's aggregation of members and also aggregation of advisors. Okay. Now when we say one like this, it's 1-to-1. So 1 and 1, minimum 1, maximum 1. Okay. Now composition is something like this: chair, All right, so when you delete the chair, you have to delete all the objects that are associated, that compose it. Okay. Now, if you cannot describe the relationship with the is made of, then don't use aggregation or association or composition, just use a general association. Now, I've seen that sometimes some people, just because there is an array of something else, they describe it as an aggregation. But let's say if you are, a student may have an array of contacts. Can we say that the student is made of contacts? No. No, it's just like you have an array, you need access to multiple instances of a certain type of objects. It doesn't mean that it is made of it. Okay? So if you can't describe the relationship with is made of, then just use general association. Like finally, the last type of relationship is the inheritance, and we've seen that inheritance before when we talked about the employee and the manager. Now, if you can describe the relationship with the is a term, then use inheritance. If you can't, then don't use it. So employee, manager is a employee, so that's a proper use. Circle is a shape, so that's a proper use, right? Yes.
Can I add something after the class?
Sure. Okay. So it's not just because, you know, when we talked about the inheritance, we had this, we learned that the fact that you can reuse the code implemented in the parent, right? So when you have a child, inherit the code from the parent, you don't have to rewrite it. So that's the reusability part. Like some people are tempted to use the inheritance relationship for this reusability part. So there's code implemented and they want to reuse it, so they just make it inherit. That's not proper use of inheritance. It's a bad design. Okay, we're gonna talk a little bit more what does it mean to design software system, but this is today we're just talking about the general notation of the most popular model, which is the class model. All right. Now, if you can't describe the relationship with is a notation, then don't use inheritance. All right, so that's pretty much all about class diagrams, or what we care about in the class diagrams. Any questions? Okay, so as part of the project, I'm gonna ask you to create, like, design your code in class. It's not just code that you need to submit. There's a design portion of it, so make sure to understand it. Okay. All right, so that's all what we have today.